Okay, here's the data in the 4stocks spreadsheet, and I've already taken it from its original form, gone through the pivot table, copied the pivot table values over here, and now I want to get the return. So control down, come right here, equal average. So as I type average, when it appears, I tab, come to here, period, control up, go down 1. Now I have rows 2 through 97, annualize it, multiply by 12. Then I can copy this across. Let's make it look good, so we'll have this in percent format. Note I've frozen the panes here, so this goes from 4 to 79, so I just have to tab or space through to make that show you, so you see rows 4, 5, 6, and so on. Now I want to have the covariance matrix, so I go to data, and I see I have the data analysis tab. If you don't have that tab, you go to Excel options and you go to add-ins, and from add-ins you select analysis toolpack, you click go, not OK, you select the ones that you want and you click OK. I'm just going to click cancel because I have it here. So data analysis, I go to covariance. This is in alphabetical order. Just follow the prompts, the input range. I'm going to put in all of this including that first row. And make sure, by the way, you've gotten rid of this grand total column at the bottom. And because I have the first row there are labels. I say labels in first row. Where I want the output to go, I can choose that. Let's find a good place for it. Let's put it right there. Click OK. Because the labels are in the first row, I have the titles right there. Now to copy this, select all of it, Control C. Come down here, Control V. Control C to copy again. Click right here and then paste special. Paste special, what I want to do is the values, and the values is so I don't copy this underline portion, which you can't really see but is still right there. Skip blanks and transpose, so I'm going to take this and flip it over or transpose it, but I'm not going to do the blanks. Click OK and escape, and there we are. So I'll get rid of this, just clear the contents. Get rid of this underline right there. I come home and I choose the option that says no borders. Then I need to annualize these, so I want to multiply by 12. So one way to do that is just type 12, Control C for copy, highlight all of this, paste special, and I'll move this so you can see, and multiply, and it takes each one of these numbers and multiplies by 12. And then let's get them in a format we like, maybe 4 decimal places. I don't know if 4 is right, but it's close enough for me. Now I want to have the returns. I'm just going to copy this so I don't have to write it again, and Control V. I'm going to call this stock. I'm going to call this returns, and let's just put a border around all of this. So I can do this border right here, center it, underline, bold. And now I want the returns. I already have the returns, so I'm going to highlight all 4 of these. I'm going to type equal transpose, and TR transpose comes up, and then just control down to get down to here, highlight these, and notice these are all in a row. And when I do Control Shift Enter, not Enter but Control Shift Enter, then they went from being in a row to being in a column. I can see all of this. Let's put these in percent. Okay, there we go. And let's say we have, I'm going to say constant, some constant. I want to have its the constant have I don't know, let's say 2%. So now I want to do the same thing. I want to have these, Control C, right here, Control V. This is an array, so I'm going to clear that out. I just copied this so I don't have to retype, all the ticker symbols. Here I'm going to have weights. So what I want to do is I want to find weights that are going to be on the efficient frontier. I need to find 2 portfolios on the efficient frontier. And the way I do that is from this formula. I'm going to highlight all of these. I need to do equal. I'm going to multiply. Well, the formula is simple. I'm going to do matrix multiply. I need to take the inverse of the covariance matrix. So inverse the covariance matrix, and that is multiplied by the returns minus the risk-free rate. There's still more stuff to do, but I want to make sure that I have that numerator, what's going to be the numerator, correct. So I do Control-Shift-Enter. Yeah, that gives me numbers. I press Alt-Equal, and Alt-Equal says, alright, let's sum that up. And it sums to some bogus number. I'm not worried about that number now, because I haven't finished this formula. The rest of the formula define the weights of a portfolio that will be on the efficient frontier. Is I take the sum of the numerator and put that in the denominator. So the fast way to do that is to highlight the numerator, Control-C, come over here, Control-V, close the parenthesis, Control-Shift-Enter. That adds to 100%. So what I have, this portfolio of these weights in Apple, Coke, Target, Exxon, that is going to be a point on the efficient frontier. That would be the optimal risky portfolio if the risk-free rate were 2%. If the risk-free rate were 1%, then this would be the optimal risky portfolio. I want to find two different points on the efficient frontier. I'm just going to copy over to here, and I just need to change this. And when I change it, this is the right formula, but it doesn't have things in the right place. So I can just drag that over there. I can drag, whoops, that should say right there. And drag. I gotta get it. It's faster for me to do it this way than messing with the laptop. And here, this has got to go over there, and this goes right here. So I have that same formula, and Control-Shift-Enter, and the weights are the same because the constant is the same. Let's change that constant to 5%. I'll do this one at 2. That's what we did in class. So this is the optimal risky portfolio if the risk-free rate were 5%, but the risk-free rate doesn't even exist. We're just trying to use the geometry to draw this appropriately. So what I need to do next is I need to find, like I'm going to do two different portfolios. Call this portfolio 1 and this portfolio 2. I need to have the returns. So I need the risk return and relationship. I have everything down to two assets. Let's call this the assets. And we have assets, we have portfolio 1. And I'm just going to make this a little bit bigger here. Drag this down. And that tells us, oh, you must want portfolio 2. Bold, underline, center. So these are the returns. So the returns for portfolio 1 are equal to the weights of the portfolio times the returns. I can do that from sum product, tab, the weights, times the returns, and hit enter. The other way I can do this, and I'll do it for the other portfolio, is I can say matrix multiplier and transpose the weights are the returns, whichever one, and then multiply that times the returns. That's a little more involved, so it'd be easier to do the sum product, but whichever way you want to do is going to be fine. And I did that with the same set of weights, so let's change those weights. That way you're coming up with the same number. Let's change it to these weights right here. Control-Shift-Enter. And so these are the returns for the two portfolios. Now I need to have the covariance matrix. So I need to have something like this. Have the portfolios 1 and 2, and then I can just paste special and transpose, and there are my portfolios 1 and 2. So I need to have the variance of portfolio 1 that's equal to matrix multiply, and a matrix multiply again, and then the transpose of the weights for portfolio 1 comma, the covariance matrix, close parenthesis, comma, the weights for that portfolio, close parenthesis, Control-Shift-Enter, and that is the variance. If you wanted the standard deviation, you would just take the square root of that, but I don't want the standard deviation now. I want the variance. Let's do the same thing for portfolio 2. For the variance of portfolio 2 is matrix multiply, then matrix multiply again. I didn't type that in right, didn't like that. Transpose, I'll transpose these weights because that's the weights of portfolio 2, comma, multiply by the covariance matrix right here, close parenthesis, comma, multiply by the weights again, close parenthesis, Control-Shift-Enter, and that is the variance, if I've done that correctly, the variance of this other portfolio. And then the covariance is equal to matrix multiply, transpose these weights. I could do it in any order of these weights, comma, now the covariance matrix, close parenthesis, comma, and now the other set of weights, close parenthesis, Control-Shift-Enter. And that is my covariance between those two. Alright, and then the covariance here is just that, and we'll format it. So now we need to draw the efficient frontier, and let's draw the efficient frontier starting right here. Let's make this smaller, and I'll start in this row 12. So the weight in portfolio 1 and the weight, just drag this over, in portfolio 2, make this 1 equal 1 minus that. I want to have 100 points here, so I'm going to say this minus the difference between those 2 points, F4 minus this, F4 divided by 100, copy this down, and then I'll go down 100 rows. So we need to stop somewhere around 112. Need to go a few more. And then let's format that to make it look good. Okay, so now we can change this to 2 if we want to, and 2 and -1 becomes -1 and 2, however we want to do it. We'll start with 1. And now I need to have the volatility of the overall portfolio, and we need to have the return of the portfolio. So what we're doing now is we have the square root of this weight squared times the variance of portfolio 1. I don't need to square that because it's not the standard deviation I'm referring to. If it was the standard deviation, I have to square it, but it's the variance, so it's already squared. But that's never going to change, so that's F4 plus this weight squared times its variance, and lock that down, F4 plus 2 times the weight of the first one times the weight of the second one times the covariance, which never changes, so lock that down and close the parenthesis, and that should be right. That's the volatility of this portfolio 1, which is the same as the square root of this number, so it looks like we have that right. And then the return on the portfolio is the weight times the return of portfolio 1 plus the weight of 2 times the return of 2. Now this should look exactly like what we were doing when we had just 2 assets. So let me double click this down, set up to look a little bit better. So what we've done here, and I'll draw the line in just a second, we've taken these 4 stocks, Apple, Coke, Target, and ExxonMobil, and we've said, look, here's the risk and relationship of those 4 stocks. Here's the return of those 4 stocks. Let's pick those, the weights we'll put in each in such a way that that point will be on the efficient frontier. So these weights, using that little magic formula, result in this return and this level of risk. These weights result in this return and this level of risk. These weights on those 4 stocks plus these, along with these weights on those 4 stocks, their relationship is described by that covariance, which is this number right here. Okay, so let's graph this and see what it looks like. Maybe it's going to look good, maybe it's going to look bad. We're not really sure yet, but we can be hopeful. So insert scatter graph without the lines, and that should show up right here. And that doesn't look that good, but there's a reason. Alright, so just a second, I want to move that. Okay, I moved that to where we can see it a little bit better. Maybe I need to put it up a little bit higher like that. Okay, so what's going on here? We have a curved line, but it doesn't look curved because that's like a real close-up of a curved line is going to look straight. So let's change the range. Let's make this go out a little bit further. So I change this from a 1 to a 2. That starts to curve a little bit better, make it to a 3, and now that starts to look like the efficient frontier that you know and love, right? So now I feel like I have that right, or I have that correct. Let me show you something else. If I take this and change it to a 0, see how I made that line longer? Because it's picking a different point. Change that to a 10. That makes the line look different because it's picking a different point. Change this back to a 2. It's just drawing different portions of that line, so we know we have 2 points on that line. It doesn't matter visually which points I draw. I know I've drawn that correctly. Okay, so let's go to the next part. We say we have a client that comes in. Alright, client number 1, and he wants a certain return. And given he has a certain return, he's going to have a certain volatility or a certain risk. And with that volatility of that risk, he's going to invest in these stocks. Let me make that list right over here. And how much does he put in each one of those stocks is going to be my next question. So first, the guy wants a certain return. Let's say that return, let me put all this stuff in percentage right now. He can get a return of 20%. See, that's right there. So I know I can get a 20% return. I'm supposed to have this in percent. So I have that at 20%. Well, what I need to do is find the weight in portfolio 1 and the weight in portfolio 2. And then once I have that, I can find the volatility. So we've done this with just 2 assets, and the solution to the weight in 1 is equal to the client's return minus the return on portfolio 1, which is right here, divided by the return on portfolio 2 minus its return. Enter. And then this is going to be equal to 1 minus that. Okay, I did that. I switched those around. Let me do this correctly. It's going to be equal to the return of the client minus the return in portfolio 2 divided by the return on portfolio 1 minus the return on portfolio 2. And there we go. So just to double check to make sure you have this right, the weight in 1 times its return plus the weight in 2 times its return, that should equal 20%, and it does. So that's a little check that you can do. And so now what's the volatility of that? Well, the volatility of any portfolio with 2 assets is the square root of the weight in the first one squared times the variance of that portfolio plus the weight in the second one squared times the variance of that portfolio plus 2 times the weight in one times the weight in the other times the covariance of the two. And oh, what did I do wrong here? So this squared, there we go. So I have, again, just to show you here, and I don't have it quite on the screen, but it's going to be the weight of the first one squared. It's the weight of this squared times the variance, which I don't have to square because that's already squared, plus the weight of the other one times this, plus 2 times each weight times that. Now the question is, does that make sense? Let's see if that can make sense. Well, a return of 20%, a volatility of 20%, return of 20 and volatility of 18. Look at this, return of 20, the volatility, could that be 18.37? It certainly looks like it. We can go down here, this page down, and we see a return of 20, and the volatility, return of 20 should be right about here, somewhere between here, and the volatility is between 18.1 and 18.9. So that makes sense. We have that number right. So how would you invest in Apple? Well, I would invest in Apple. I would take the amount that I have in portfolio 1, lock that down, times the weight of Apple in portfolio 1, plus the weight in portfolio 2, lock that down, times the weight of Apple. So for Apple, I would have 39.67% because I take 118% times the weight in one minus 18% of the weight in this other one. Copy this down. Can't get this to move. Copy this down to here. That should add to 100, alt equal. That adds to 100%. So this is what client number 1 should do. You should say, if I want this return, and this is the return that he puts in, so let's put that in blue and bold, then the results are right here. These are the weights that he'll wind up with, and this is the volatility that he should expect. Okay, given that, see if you can get your way through client number 2. He would have a certain volatility they would want, and that volatility, let's say the volatility is 20%. Okay, so how would you go about doing that? Okay, so I paused it there just to move a couple things around. Move client number 1 over here, just for space reasons, and then have client number 2 come right here, and he's not going to want to have a return. He's going to say the volatility I want is some amount, and then we're going to find his return. So the question is, how do we do that? Well, let's say his volatility that he wants is, let's put 19% in, and then what return should he get? Well, I need to find the weights in 1 and the weights in 2, and the way I need to do that, this is going to be expanded a little bit, so let me change the way this looks. I'm going to have, my A, B, and C, like we've done before. Okay, so for A, like I'm solving the quadratic equation, A is going to be equal to the variance of portfolio 1 plus the variance of portfolio 2 minus 2 times the covariance of the portfolios. B is going to be equal to 2 times the covariance of the portfolios minus 2 times the variance of portfolio 1, and C is going to be equal to the variance of portfolio 1 minus the variance that the client is asking for, that's the standard deviation is asking for. So then I simply square that, and those numbers I want to format. I don't really care what they are. I don't have to look at those individually. So my weight number 1 is going to be equal to the following. It's going to equal minus b. Actually, I do it this way. Equal to minus b plus or minus. So let's do plus the square root of b squared minus 4 times a times c, close parentheses, divided by 2 times a. So close that. That gives me the weight in one, and equal to 1 minus that. That's the weight in the other. So this is one possibility. Let's see what that return is. That return would be equal to this times the return of portfolio 1 plus this times the return of portfolio 2. And that's 65.8%. Let's see if that makes sense. 19%, it doesn't. So let me check and see if I entered something in wrong, because if I have a 19% volatility, I should have a return somewhere around 20%. Okay, so I'm just doing this run through one time, so I gotta just correct the mistakes without editing. I just hit the wrong thing. So what I want to have is 2 times the variance of portfolio 2. I'm sorry, 2 times the covariance of the 2 minus 2 times the variance of portfolio 2. That's B. And C is going to be equal to the variance of portfolio 2 minus this, which is going to be squared. And that comes out to be minus 5.37%. Yeah, that could be minus 5.37%, but I don't think that's the one we're going to want to have. So I'm going to do this the short way instead of doing, I would rather you do one with plus, one with minus. But let's change this to the minus right here to do this more quickly. Yeah, that's the one I want, because that's 19%, 20.8, that works out. If I look at the volatility here of 19, see that was around minus 5, and then the volatility as I go down, I'll see 19 again, and it's in the 20% range for return, which is exactly what I have. So then my apple is going to be this weight, and we'll do F4 for that, times that weight plus this weight, and we'll do F4 for that one, times this, and then we'll copy that down. And so someone doing this particular portfolio, if you want 19% volatility, you can get a 20.8% return, and you have 42% in Apple, 51% in Coke, just under 1 in Target, 5% in ExxonMobil. You want to take more risk, say 21%. That's what your portfolio would look like. And again, we have, this is going to be plus or minus b, plus or minus the square root of b squared, and all that with the quadratic equation. I'm just for making it quick and easy, I just did this by hand. I did the plus and the minus. I want you to do both of them and see which one's the most. And the final thing, client number 3, would just be, I have the minimum variance portfolio. I think you can handle that, so I'll leave that part unfinished.